Video 2. Linear regression models. An empirical analysis uses data to test a theory or to estimate a relationship. How does one go about structuring an empirical economic analysis? Once an econometric model has been specified, various hypotheses of interest can be stated in terms of the unknown parameters. After data on the relevant variables have been collected, econometric methods are used to estimate the parameters in the econometric model and to formally test hypotheses of interest. An empirical analysis, by definition, requires data. Economic data sets come in a variety of types. Cross-sectional dataset consists of a sample of individuals, households, firms, countries, or a variety of other units taken at a given point in time. Different variables sometimes correspond to different time periods in cross-sectional datasets. However, the ordering of data does not influence econometric analysis. A time series dataset consists of observations on a variable or several variables over time. Unlike the arrangement of cross-sectional data, the chronological ordering of observations in a time series conveys potentially important information. Pooled cross-sections have both cross-sectional and time series features. These datasets allow to expand the sample size. Although the order in which the data are stored turns out not to be crucial, keeping track of the year for each observation is usually very important. A panel data or longitudinal dataset consists of a time series for each cross-sectional member in the dataset. The key feature of panel data that distinguishes them from a pooled cross-section is that the same cross-sectional units are followed over a given time period. The equation defines the simple linear regression model and addresses the issue of the functional relationship between a dependent variable, y, and independent variable, x. The linearity implies that a one-unit change in x has the same effect on y, regardless of the initial value of x. A simple linear regression model basically assumes that: first, the average value of the error term, u, in the population is 0, and second, the average value of u does not depend on the value of x. Taking the expected value of the simple regression model conditional on x, the population regression function is a linear function of x. The linearity means that a one-unit increase in x changes the expected value of y by the amount of beta 1. The population regression function, estimated through ordinary least squares, is the sample regression function. The name ordinary least squares comes from the fact that these estimates minimize the sum of squared residuals. Linear relationships between the dependent and independent variables are not nearly general enough for all economic applications. To overcome this issue, it is rather easy to incorporate many nonlinearities into simple regression analysis by approximately defining the dependent and independent variables.